Okay, the issues should be solved now because I just checked it and everything should be fine and there should be sound. So sorry for the inconvenience, and Fernando, could you start your presentation about rendering applications in 3D? Okay, I was muted, sorry. Fernando, it should be okay now, so could you start your presentation? Sorry for the inconvenience.
Yeah, no problem. So you guys see my screen all right?
Yeah?
Great. So let's start. So my name is Fernando Estavillo. I'm a software developer. I've been a software developer for about 12 years now. A very fruitful and fun career. I'm originally from Mexico. I come from Poland, and I currently work at IPAM. So yeah, let's get this started. So this is a very interesting talk because there's a big gap. So I will show you guys. So yeah, let's start with 3D on the web. It had like very humble beginnings. All of this started with WebGL, which is the web graphics language. Um, so yeah, what about the web graphics language? So I'm gonna show you guys this thing. So the whole idea behind WebGL is to have a standard language to express 3D graphics or 2D graphics on the web and have them be rendered by the GPU itself. So it's hardware accelerated graphics. But there's a catch, and the catch is that WebGL is very low level. It's very difficult to do, and even the documentation says right here it's not for the faint of heart. It's really difficult to get started on this thing because you have to do a lot of code to do very simple things, and so it's a lot of code. It's difficult code. It's tedious code because it repeats itself all over and over and over and over. And this thing is very useful, and it's like our first step. But you cannot use this in a project. Like this works great when you're trying to render, I don't know, a cube, which I will show you later. But when you have a bigger scene, this will not help you, and you will see why. So this is an example of WebGL. So I made this little cube with WebGL, and I took this example from their documentation. So as you can see, you have to do everything. It's very, very manual. So you have like all of these vertices, you have the colors, you have the indices, then you have the shadows and the texture somewhere here. And as you can see, it's almost 200 lines of code just to draw this simple thing. So there must be a better way. So yeah, that's how it works behind the scenes. So enter 3JS. 3JS is a great library. 3JS is the modern 3D of the web. And it's not even new. This thing has been around for like 10 years. You can go to the 3JS website and check it out. But basically, all of these websites were made using 3JS, and it has become in many ways. So it's like is what 3D developers use. So this is an interesting thing. This has caused a divide since there's front-end developers, right? And we mostly do like UI work and web applications and such. And then there's 3D developers. So now we have two different things going on, and it's very difficult because when you're looking for somebody to work on a 3D application, you're not looking for a JavaScript developer or for a UI developer. You're looking for a 3D developer because this kind of thing has a lot of concepts that are very, very, very specific to it. So even if you're a great front-end developer, you may struggle when starting with 3D. So one of the fun things about 3JS is that we simplified. So if we go back to this thing and we see like all of the code that we have, and to make just a box, it shouldn't be that hard. So this is the code for a box in 3JS. So 3JS is an abstraction of WebGL. So behind the scenes, 3ds is doing the WebGL for you, but it gives you a very easy interface to use. And we have like all of this documentation, all of these examples on how to do things. And I made another tiny demo here. So this is what it's similar. It's not exactly the same to the other cube I showed you. Actually, this doesn't have any shaders or whatever, but it's just a box. And as you can see, we're already on a very good point, because we don't have all of that code anymore. We had from almost 200 lines, we're down to 30. So that's a great win. So yeah, it's not all smiles and roses with this thing. Like, there's one more problem for front-end guys when we're trying to get into 3D. So this thing works great, and it's a great abstraction of all of the 3D stuff, but it still has a very imperative syntax. So if you want to render a cube, if you want to render a light, if you want to render a light, a camera, whatever, you have to declare it manually. And whenever you need to update your state or your properties or whatever, you need to do it manually too. So as you may be able to tell, that makes things very complicated. So when we're doing a scene, something that doesn't move or something that's just a static thing that you want to see, this is great. But when you're trying to do an application where parts move, where things happen, it can be very difficult to manage that state and to have like all of these positions in place. So basically here I am declaring like every movement, everything. And for instance, I will do just one rotation, then the other rotation, and then I'm gonna do the same with the camera. The thing that's happening here is that every time we have a frame of the animation, every time we do the calculations again. So if you want to do a more complex animation, like I don't know, like if you wanted to do like on a sinus line or whatever, you will have to do the math yourself on the library itself. And that can be just very difficult, especially when you have different positions. So when you click here, this goes there, and when you go there, this goes here. It can get very complicated and very difficult to maintain. So now we have two solutions, and we still have a problem. So that brings us to the next part of this conversation, which is the thing I'm telling you about, like where we're at. So we're at this point where 3D is a competence on its own. It's something you have to learn. And the front end is something else. So having a person that does both things is very difficult. It's just not very common. So because of that, right now it's on very high demand. There's a lot of work for this kind of stuff happening. And the thing is, like, okay, we now have this huge divide between front-end developers and 3D developers. So, or 3D talent, I think that's what they usually call it. So how do we fix this? And that's the main point of this talk. Like this is like, just for context and introduction, this is the real thing. So React goodness. So why would we want to handle the state and do like all of this coding when we already have React? And React is great at doing that. You have hooks, you have a state, you have props, you have components, you have all sorts of things. So the thing I wanted to talk to you about is React Tree Fiber. React Tree Fiber is a library that pretty much attempts to bridge that gap between the 3D talent and the front-end developers, making it way easier and way more manageable to do complex applications in 3D. So yeah, let's take a look at it. So I made this little example. It's 27 lines, but it's way more. It's way better. So what I wanted to show you guys here is, okay, here I'm rendering a box, and this box doesn't do much. But here's the interesting part. So we have a box, and we made it into a React component. So we have a React component with the box inside, and this is doing the same thing as React does and as 3JS does. It's just forwarding the properties for 3JS. So we're rendering React components in a 3D space, and I think that's amazing. Like that's not something I could do a few years ago. And it's really empowering too for developers, because I've done lots of applications with React, but 3D for me is very complicated. And now I have like all of these tools at my disposal, and I've been able to do things that are really useful and cool in a very short time, because this thing is easy to learn. There's a great community behind this. So the main idea behind this talk is not to give you a class or bore you to tears with stuff. It's really to spread the word on these libraries, and to have people download them, use them, play with them, and if everything goes well, contribute to the code and the community, because these things are great. So let's take a look at what we've got here. So we've got our canvas, which is pretty much where we draw our stuff. I have some pretty standard stuff like some light for the shadows and such. And then I have the box. This is probably the most interesting thing, because we have a box, and then I don't have to go through all of the motions that React does, the 3JS does, to make new boxes, for example. So now I have a bunch of boxes, and I apparently broke one. Let me refresh this thing. Yeah. So as you can see, this made a little bit of a rectangle, because the boxes are on top of each other. Let me make the gaps a little bit bigger, so we'll be able to see the individual boxes. There we go. So we have 4 boxes on top of each other, which is great now, because if you go back to 3JS, I will have to do this for every box. But now I have a modular component, and I can just copy paste it and do and have fun with it, basically. So yeah, the interesting part of this is that you can create your own custom components just on React. So right now, all of my boxes are blue. So let me fix that real quick. I'm gonna go 1.2, and I'm gonna get these guys there, so it's more apparent that they're 3D. So right now, all of them are blue, and I can change the color, changing the material color. So I can do something like orange, or maybe pink, and I'm changing them all together. But what if I give each one of them, like I'm doing with positions, I can give them their own color. So you're blue. Yeah.
Excuse me, Fernando.
Yeah.
Could you just zoom in the font a bit?
Yeah. Is that better?
Yeah, one more.
Let's try one more.
Is it okay for you? Presently, yeah, it will be great.
Awesome. So yeah, right now the color is hard-coded, so every single one of these boxes is pink. But I'm adding a color property here, which will be blue, orange, and this is probably my favorite color in HTML, hot pink. So yeah, now instead of just hard-coding the color here, I can just receive a prop, like we do with React, and use the color there. So prop. I missed a letter. There we go. Refresh. This should work. There we go. So now I have 3 boxes with three different colors, and I can do all sorts of things with this thing. So for instance, we have a hook that is use frame. So this is similar to the thing we saw before in 3JS. We are doing this with the frames. So if I wanted to do that same thing with the frames, I could just uncomment this line, and I'm setting the rotation of all of these 3 boxes, and now they're like dancing all together at the same speed. So yeah, probably I want one of them to be faster, one of them to be slower. I can do exactly the same trick. So I will do speed, and this one will be 1. So if there's speed on this thing, we pretty much will have the default speed plus the speed that I'm sending in the properties. So yeah, this one is going crazy now. And the other ones are not working because the sum is not giving me the right thing, but I could do something like this. Sorry. I'm just gonna declare it here. Bar extra speed equals props speed or 0. No. Prop speed, and 0. So yeah, now we can have our extra speed, and the slow ones will remain slow, and the fast ones should go faster. There we go. So we have our crazy blue one and the other ones that are slower to make this a little bit less crazy. So yeah, it's pretty much all of the power that we have with React, but in a 3D space, and this can do a lot of things that are very, very interesting. So what else can we do with this thing? We can do a lot of things. So for instance, when you have something in 3JS, it's just an object. It doesn't have any state. It doesn't have whatever. So that's the state you have to manage somewhere else. The difference between these boxes is that now we have a state inside of this thing. So let's do this thing. So for instance, let's use the state. So constant is hovered. For instance, we could use state to be false by default. So yeah, now what? That's not normal. So, oh yeah, sorry. I have to do is hovered and set is hovered. So yeah, we now have a state inside of this thing, and that can be absolutely useful. So yeah, stop complaining, Jesus. Okay, so now we have a state, and we can do fun stuff with this state. So for instance, let's say I want to do. I will actually do is active, and then I will do set is active. So the fun part about this thing is that now that we have a state, we can do a lot of things with it, and we can actually use regular React events. So for instance, I can add to this mesh an on-click event. On-click event, we're gonna do a tiny anonymous function, and then just go with set is active to whatever is active. So this will be pretty much a toggle. So every time I click it, it will do something. The problem is that I am not doing anything right now with the variable. So let's do this. When this thing is active, it's gonna be bigger. So basically I'm gonna do like 1.5, 1.5, 1.5. So now that we have these values, whenever I click a box, it will become bigger because we now have a state. And each one of these boxes is a replication of the same module with an independent state. I could give you guys more examples and do like crazy things, but I think this pretty much proves the point in that sense. And there is a lot of things that you can do with this thing. Another thing I wanted to talk about today is not about just this library, which is great, but the ecosystem, because I think that's what makes it greater in the end. Like this library was developed by Paul Henschel. I must be butchering his name, but that's his name. He's from Switzerland, and he's very active on the open source community. And I really admire the guy, and I really want to spread this work for for everyone to see. So we have the ecosystem, and the ecosystem has a lot of libraries that are very useful to us. So I wanted to showcase some of these libraries for you guys. So we have use gesture, which pretty much it works with React Tree Fiber. It's that's why I mean with ecosystem, like these libraries are interconnected, sometimes by their authors or sometimes by other people. But yeah, they're like they work very well together. So we have use gesture, which is a great library that you should use with React Tree Fiber because it has a lot of useful things. So for instance, when you're working on a computer, the drag and drop works with mouse events, but when you're working on a phone, it's with touch events. So this thing pretty much unifies everything. So you will use a single API to target both cases. Another interesting one is React Spring, which I've been using in many projects right now, which allows us to do animated matrices. So, for instance, this one is a mesh, but I could do with React Spring an A dot mesh, and then you get to skip all of the math that I'm doing here, and you get to animate properties. So anything that can be a number can be animated, and that's very interesting. It allows for some very special effects. Another thing I wanted to show you guys, and I think this is especially fun, is Canon.js. So Canon.js is an extra layer on top of this thing that allows you to use physics in the 3D world. And that can be very fun to simulate. I actually made a little example for you guys here. So I have a bunch of boxes with different colors, and they exist on a 3D space. And when I refresh this page, they pretty much fall all over, and they bounce and such. And I think this, especially for game development, can be a very fun mechanic. And you can simulate things instead of animating them, and I think that's very powerful. Canon.js is a very interesting tool, and this is pretty much an emerging library. This is something that has not like yet hit like the mainstream. It's a smaller community, and it's very close together, and I think this kind of tools can make you a very expensive developer, if we could say that, because there's not a lot of people that are actually doing this or that actually understand what's happening. So right now there's a lot of demand for this kind of thing. Yeah, one last library I wanted to showcase, guys, on this ecosystem is React XR, which is virtual reality for this thing. So if you have a headset or a phone even, you could do some pretty interesting stuff with virtual reality or mixed reality. I personally haven't used yet, but it's something I will do in the near future because I think this is very interesting, especially now that we have a lot of innovation in that sense, and I think this can be very fun to play with and to be like a pioneer of virtual reality on the internet, on the web. So yeah, I think that's that for the presentation. I don't really want to dig like very deeply into these things. I think that's something if you're on LinkedIn, I put it there somewhere. It's just my last name, and yeah, I'm available all the time, and I really like this thing. I have struggled with it. I have done a few applications with it on my own time, and yeah, I think this has a lot of potential as a growing technology. So yeah, that was it. I hope I didn't bore you too much, and now it's open for questions. If anybody has questions for me, I will be happy to answer.
Okay, thank you for the presentation. That was actually very, like, I didn't expect to learn that much, and it, for at least for me, it will be very, very useful in the next like 2 weeks or 3, because I'll be doing,
Really?
yeah, actually, because I'll be doing like this thing, like a presentation as well, but from like my team, and we'll be discussing the different ways of displaying information in 3D. So basically, we'll be mostly we were thinking about discussing the D3JS, but well, now I can add something more to it, which is actually perfect. I don't think that we have any questions, at least.
Yeah, Alicia, can you hear me right now? I was talking on mute in the beginning. In this gap when there's no one talking, actually, I was talking. Sorry. So we don't have questions. I think most of us are very impressed. The smooth how it works. It's just unbelievable. We always struggle with this smooth animation to make them smooth, not expensive to CPU, and all the stuff you show just show us that we can make these amazing animations and work so well. So I would ask you maybe.
Yes.
Yeah, there's a ask for if you could share the code in some way. You could, for example, create a Git repo and we could share it under the, for example, recording.
I actually made a bunch of code sandboxes. These are all public, so pretty much I will share them. If I share them here in the chat, would you guys get it?
Share with me and I will add them beneath the video.
For sure.
It will be...
And then we have, I will actually comment this one line out. We have the 3JS example. Okay. And we have this last one, which is the React Tree Fiber demo.
Oh, we
And
just got a question. Do you think that things like this, like 3D games, will move to web browsers instead of native Windows applications?
No, but here's the thing. The application of this is very different. I think the most interesting part of this is that it's on the browser. So you don't have to download an app, you don't have to download anything, install anything. It's just, you just open your browser and it will work. That's one thing. And the second one is that this allows you to target any platform that has a browser. So you can run it on a phone, you can run it on a tablet, you can run it anywhere pretty much. And that's very interesting. Sometimes you don't have the resources to make a native app for every platform that you want to target. So this is a great way to target many platforms at once with a single code base.
Thank you. Actually, I have something to add to this question, because like I agree that I doubt that 3D games will move to web browsers from Windows applications, but from what I know about game development right now, I know that some some studios that are developing the games are actually using React when they're preparing UI, for example, for the menu. So there is like a web JavaScript and React in game development, but not in the way that we would actually expect it to see.
Yeah. This is another important thing about this library is that it also allows you to put HTML inside. So you can mix both. Like you can have 3D HTML if you want to. I don't know why you will do that, but I can see how it can be useful.
Yeah, it is. For example, from like known games like Riot Games and League of Legends, their client is written in like JavaScript. They decided to move to it like I think 2 or 3 years ago. So yeah. And yeah, when it comes to the list of open source libraries, we will get them from Fernando and we will share them on like in the chat.
Sure.
Yeah, I think I will add them below the video. So if someone watches this in the future, he will just get it.
Yeah.
Of course.
So that would be probably, guys, any questions more? The links. Yes, we will share all the links. And Fernando, do you think that there are also something similar for other frameworks, or this is very much React specific?
Yeah, I mean, I have seen a couple projects that are similar with Angular, but I don't think they are as good, and I'll tell you why. The most important thing about React Tree Fiber is that it pretty much forwards everything to Three.js, so it can run on pretty much any version of Three.js, and if Three.js makes changes in the future, React Tree Fiber will keep working. So when I started using this library, I was looking into other options, and why I didn't choose the Angular ones is that those are pegged to a version of Three.js. So if they do a Three.js update or something like that, it will probably break. So what this thing does, it's not adding much code of its own. It's more like just an interface for Three.js, and Three.js is not going anywhere. I think Three.js is probably what 90% of the 3D projects on the web right now, I think.
All right, thank you.
Yeah, thank you.
Alicia, I think right now we can announce a short break. Then we switch to a different place where we will broadcast another talk.
Yeah, that's exactly what is on our schedule. So thank you all for watching this presentation. I hope that you still will be us after the break. The break will take no longer than like 10 minutes, so just keep checking up on us. Just make yourself a nice cup of coffee or tea and get comfy. And next we'll be talking with Fatih about an actual game development with JavaScript.
Awesome. Well, thank you very much, guys, for having me, and we'll talk later.
Yeah, talk to you later.
See you soon.
guys. My name is Fatih Erikli, and I will be giving an uh, online workshop about game development today. So my name is Fatih, and I work in EPAM Systems in Poland. And first of all, I would like to explain some things about game theory because it's the main concept. Actually, yeah, we can consider like everything as a game, and it's a process like called gamification. And there is a theory which is focused on that. It's called game theory. It's the study of strategic interaction among rational decision makers, and actually. It has applications in all fields of social science as well as in logic, systems science, and computer science. And originally, it is addressing to zero-sum game. Actually, this is valid for all the applications that we use every day in our daily life. So it can be a dating application or social media application or whatever. Actually, we can consider everything as a game, like in computer. Actually, the computer itself is working like a game as well. This is the game. It's zero-sum game. So it means you cannot earn money uh, by just clicking the buttons. So when you get something, you lose something, or vice versa. And yeah, so how do we design, how do we create a game? The first move. So creating a game is actually a game as well. So first thing you need to do is creating a license file that describes your intention about that game. But the license file is just a text file, or it could be a paper. I mean, you don't even need to use a computer to create a game. You can create, it can be a theater or something like that as well. So the first thing we need to do is creating a license file, and it can be edited later because you are the owner of that game. Then you can change the license file, and you can update the game according to your original intention, but you cannot basically update the license file in order to get more profit from the game because you lose it from the other side. That's what is about.
I'm sorry.
So you can,
I'm sorry. I need to interrupt you
yeah,
for a second because I need to restart something because there's like a data connection. Just give me like 30 seconds.
sure. Mhm.
Okay, it should be better now. Sorry for the inconvenience.
No, it's fine.
Did you pay the bill, Alicia, for the internet?
I did. I
Should
did.
be fine.
It should be better now.
Yeah. Okay. If you guys see again something wrong with the speed or with the video, also write in the comments, please. Thank you. Let's go back.
So it can be relinquished. It means like you can even change the words. You can invent a word. So the license file is like the language part of the game. So you don't worry about it. Just write a poem and or something like that. And yeah, or you can just start with an MIT license. You can Google what MIT stands for, but the MIT license is a reasonable approach for starting a project or a game. So the license file is like something like that. And yeah, so then the next thing you need to decide about the name. And like for me, to be honest, I think explicit is better than implicit. This is also part of a poem. So here's the name that I chose. Maybe you maybe you know that game. This is called Flappy Bird or Floppy Bird or something like that. But actually this is not something that somebody can take the patent of it or something like that. This is just a bird trying not to hit to the pipes coming through. So, so you can decide about the name like that. This is my name, a bird trying not to hit to the pipes coming through. Or it could be Flappy Bird as well. So yeah, let's continue. Let's visualize the bird first. That could be a 2D image, 3D model or something. But in our presentation, it's just a rectangle in 2 dimensions. So I would like to, explain the game first. So this game, you're trying to press some button, and when you press the button, the bird jumps actually, not flies. So the bird is something like that, and the bird should be falling when the game starts, and you press something in order to prevent the bird, the fall of the bird. So it's something like that. So the bird is falling, then you press a button and you need to make it up. I mean, this is the main logic. So and we need a background for the game, something like that. And the background needs to move to mimic the behavior of the bird is flying to the right direction. Yeah, like when you look at outside from your window, you'll see actually. I mean, okay, let's say one car is going like rightwards or like going to the right or left. Into the dimension, actually, we can mimic that behavior by moving the background to the right. If you just open a game and observe it, you will see actually the bird or something is not going right or left. It's just fixed position, and the things in background or around moves to the left or to the right. So we can we can move the background to simulate the behavior of the game. Sorry, to mimic the behavior of the bird. Or there was a sun here. I mean, it's white actually, but it's sun or some planet. So we can actually move the sun as well instead of moving the background. So I will try to animate it. Yeah, something like that. As you can see, actually, okay, right now the sun is moving. We also need to move the background, but this is just the presentation. So we need the bird here. Sun is here. Bird. Where's bird? Oops. Okay, this is a bird. So this bird needs to jump when we press something. So that's how we design the levels, actually. So this is the UI part of the game, and it's very simple actually. What you see in your computer screen or any game, any device that you can play a game, the part that you see is about that. We have a state and we draw the state to the screen. I mean, it doesn't have to be drawn to the screen, or basically you can. I mean, like yeah, it's uh, like up to your like imagination. So that's how we were designing the levels. This is called level design. And so like how do we interact with the game? So we need to listen to some input. That input can be a keyboard event like mouse event or the device orientation. I mean, if the device is in portrait mode or in the landscape mode, that something like that. The weather forecast, for instance, you can check the weather, and if the weather is rainy, the background image could be rainy or sunny as well, or vice versa. The face of your cat, basically you can use some like machine learning kind of thing there, and you can try to get some input data from the picture of your cat. And in that case, the input will be the face of your cat, and it means your cat will be playing the game. And yeah, so like anything you might consider as an input, like can make the interaction. So let's continue. So talk is cheap, show me the code. So object-oriented programming is quite reasonable approach for building games. To be honest, I'm not a big fan of object-oriented programming. Why so? Because in real world, we don't know how to define an object. I mean, okay, it has some shape, but when you zoom in, like you see that maybe you cannot even see if they are stick to something, or like I mean, there is no way to define an object. Let's say like we have a cube, but this is not a cube actually. Like when you zoom into to the corners, you will see like some not perfect parts of it. So that's why I don't. That's why I don't like object-oriented programming. But for the games, I mean, the games are zero sum up game. Like it's not rocket science, right? Like we can compromise about some details, so we can just make it object-oriented programming. Nobody will die like at the end of the day. And yeah, like so this is some sort of class. This is that can be in any programming language. Again, could be Python, JavaScript, C sharp, or F sharp, or like or whatever. Anyway, yeah, and we have two attributes: the width and height, like 500 pixel and 500 pixel. So the game is a square actually. So the yellow, the yellow part on the screen you see is like some sort of game actually. So we have a class there, like 500 and 500. We have a square of with the size of 500 pixel, like multiply 500 pixel, and we need some game states. This is the most important part. This is what makes the game as a game. Actually, as you can see, this is not just a game. That can be like social network or something like that too. And yeah, so we have in a Flappy Bird game, or that's bird game, like we have three states. So the first state is waiting. The bird is doing nothing, just waiting. The second one is playing. So it means the sun or the background is moving to the left, and the game over is unfortunately the bird is mm, I mean, the bird is not waiting anymore, let's say. So this is how do we define the game states. And yeah, like we need to define them as less as possible. Like, yeah, like, yeah, like the less is more. Basically, you can simulate any kind of game with that, like with the 3 states. I mean, you can add more states, then it will be more complicated. Then you need to observe more. Then the outputs or the predictions or something that you made from that game will be more noisy. So that's why the less is more. The less is, I mean, the less you define the state is more you get the result in a great way. So, and okay, the first square was a game class, and we have another class which is bird. And as you can see, the bird is okay flying, but the bird is not flying. Okay, the Y like indicates the vertical points, like vertical point on the screen. So yeah, 0 means the bird will start from the top left of the screen. So the bird starts in 0 states, and the bird also has states. As you can see, we have game states and we have bird states. So it's getting complicated already. Like that's why we need to define the states as less as possible. So, and the bird has 3 states: fly, rise, and the fall. So the bird is starting in fly state. Sorry, there's no default state here yet. Okay, so when the bird will be like flying, it will just continue to the right. I mean, the background will be moving to the left. And when it's like flapping, it will be the Y, I mean the here, Y or Y will be increasing, and in the fall state, it will be decreasing. So that's how we instantiate a game. It's const game. The game is an object in that case, but it holds state, but the declaration is like the const game. I mean, we will not assign any other game here, so like the state will be safe. So we define it with const. And the bird also could be like, or can be instantiated in that way. So yeah, like actually, I mean, that's how the code looks like. I mean, you can implement that code in any framework. Like you don't even like, I mean, you can just create an index.html file and you can just start writing JavaScript and you can run it on your browser. Like you don't even need to install game engine or something like that. Browsers are like much more powerful than the game engines right now. Thanks to the technologies such as WebAssembly and web workers, etc. Yeah, like in flap state, when we receive an input, if the game state is not a game over, we are decreasing the vertical speed, and we are updating the state of the bird. Like it means like it's flying, it's departing, or like it's going upwards. And like that's how we handle the events. Like for instance, on mouse click, the bird will flap. So yeah, that's the presentation. And yeah, also the so also I can show the code base. So actually that's this is the game. A blue square trying not to hit to the pipes coming through name game. So you can basically read this code. This is pure JavaScript. There is something like this class, but this class actually something like anyway, this was implemented in like I don't know 5 or 6 years ago. We didn't have class keyword at that moment, but somehow me and friends at that moment like tried succeeded to mimic a class behavior in JavaScript, and we did it. So like the class starts with height, like speed. As you can see, we have the speed as p number and plus some random. That's what I'm talking about. You cannot lose a game or win a game. Actually, this is just like computer simulation. It's not a game and everything. And yeah, and as you can see, there's random. Like this random value will be changed when you refresh the page. This is initialization, and this is actually this whole file is a game engine. But like it's, for instance, there's, I mean, the assets and everything is loaded on demand. Like this is new image. It comes from the browser side, and this is assets. Let's see what is assets. So assets actually pipe. Pipe is something like that. Actually, I can show it here. So this is the pipe. Anyway, so like in an update, like we are updating the X value of the pipe because pipes are moving. The bird is not moving, but the pipes are moving, as you can see. Pipes are moving, bird is not moving at all. Also, as you can see, the clouds are moving and the mountains are moving. Game over. But as I said, it's okay. I mean, so, and we have a bird class, like it has 3 states, and I listen to that event. So this is, there's some like Easter egg here, like it's not an Easter egg, but anyway, this is, I mean, everything could be considered as an input. Actually, this is a hack for the browsers. So okay, mouse down, we will flap, key down, we will flap, so we can play with the keyboard, mouse, and mouse up. It means actually this is a hack, but like everybody is doing it, and I'm doing it as well. So actually, this is a link, right? Like when I click on it, it will go. But as you can see, I can prevent clicking it. But here I cannot prevent it. Like it means like whenever you like get close to the there, like it starts and you need to play. And yeah, as you can see here, like actually this web page is a game too. So that's how the bird class is defined. We have some constants, we have ground, And so, okay, how do we draw it? But by the way, that's the game class. This is the most important, the God object, actually. This is, so we have 800 pixel of width and 500 pixel of height, and states, three of them. Clouds. As you can see, the clouds are also defined as an object. These are all objects.
I'm sorry,
And we have
Fatih.
also,
One thing, if you
Mhm.
when you're showing and scrolling, could you like do it slowly, because there's some, I don't know, pixel, I don't know, it kind of, you know, jams the screen. So if you just like
oops,
show, just a bit slower. Yeah, thank you.
okay. Mhm. Is it better? I mean, okay, I will make it slow,
Time
but
will show, because there's also also delay in what we are showing and what we are broadcasting, but like 10 at least seconds, or maybe 15. But okay, just, or maybe you can zoom in a little bit, and when you scroll, just kind of
okay.
wait
Mhm.
for
Okay,
the
sure.
font to load. Okay, thank you.
Okay. So that's how we define the clouds. And yeah, and the game starts with an wait state when we are creating the pipes. And this is actually the most critical part, because I mean, you need to create the pipe. Then when the pipe is passing, you need to somehow dispose that pipe. And this is how we handle the collision. That's the collision detection part of the. This is the most critical part of the game. I mean, it decides if you hit to the wall or not. So like it, and you need to try, experiment, and decide like how to decide. Sorry, how to like determine if it's a collision or not. Like if it collides, we are changing the game state. The game state is game over.
So we basically calculate the position of these objects, and if
Mm-hmm.
they in some way collide with each other, I mean the
Mm-hmm. Yeah.
pixels, this is the when they, okay.
Yeah, actually, how do we do that? Actually, like it's, I mean, basically, you can draw a triangle between the points and get the hypotenuse of it. I mean, probably everybody has a different word for it, but I think hypotenuse, or yeah, like basically you need to get the distance between two objects and like decide them if they are colliding or not. But sometimes it could be more challenging. Let's say the object is not it's not, it's a polygon, right? You don't know where it ends, where it starts. So the collision detection part is the most challenging part of game development. I mean, if you want to create some library in like, and if you want to build a game, and if you want to like go with it, you can first start with creating a collision detection library. Then the rest of it will come. That's how we update the score. Basically, this is something like that. And yeah, the game over screen is, it's Helvetica font. It's the another important thing. And yeah, like it's like that. And also, this is another time. So like the time is not relative. I mean, like we there is no way to understand how fast we are playing the game. So so thankfully to the modern browsers, we are requesting an animation frame, and the browser is telling you, hey, you can play or not. For instance, like you are using a mobile device and you received a call from somebody, right? Like you cannot play the game at that moment. So the request animation frame allows you to catch an ideal state of the device and uh, make it like playing. Because I mean, as I said, this is just a game. There are much more important things in our like daily life. You can receive an emergency call or something like that. Like, I mean, so this is very important. Like, and that's the fallback. If the browser doesn't have request animation frame function, we are basically setting a timeout. Like after, let's say, 1 second, the callback will be executed, and the callback is actually the loop itself. So the loop is the function that we define the loop. So it will call itself after 60 seconds. And yeah, and there are some assets here. Cloud is not showing. No, cloud is white. That's the white. That's why it's not showing. Okay, pipe. We have the pipe. Weather. Wow. And ground. And then the ground is actually mountains. Yeah, and something is missing there. And I mean, in this game, what is missing is the audio effects. I didn't do it like intentionally because this is a silent game. I mean, we have enough noise in our lives, so like we don't need sound effects in games at all. That's what I think. So I can like receive some questions.
Questions. I don't see any questions but from the audience, but I kind of have one. Some time ago, I kind of just for fun, I was creating some game with help of Canvas. It was a bit similar what you to do, but do you have any comparison to Canvas in any way?
This is actually a canvas. As a canvas is the rendering part of it. So how do we do it? Like I'm trying to remember. As I said, let's say.
Okay,
Stage.
now I see font
So
texture.
let me show how to instantiate that game, and it will be more clear. So it's defined in index.html, and okay, it should be somewhere. So this is how we start the game. This is the class that we defined in JavaScript file, and we are providing the canvas. Yeah, and when the game starts, we are changing the title like levitating, and yeah, and also like I can show the canvas is. I mean this is canvas, but it starts with display none. It's not visible. The start game makes it visible, and the start game is triggered when we click on the link, Flappy Bird link. So where's Flappy Bird link? It's here. It's the game. Yeah, that's how. I mean, like we use canvas here, but could be something else as well. I mean, you instead of drawing it to the canvas, you can make it with WebSockets, send the positions to the WebSocket, and you can listen these positions somewhere else and draw it somewhere else. So they are like loose coupled. Is it answering the question or?
Yes, actually, yeah. I was just missing this part. Yeah, so that would be the similar thing I was thinking about. And you mentioned the WebSocket, and it kind of brings me to the point that when I was thinking, can we do a multiplayer with this as well, probably?
Yeah, of course.
Yeah.
I mean, we will just instantiate more than one birds. So class game, oops, lock the game. Like we will just instantiate more than one birds. Like, of course, it will need some like retouch here, but yeah, like we can. Actually, it could be a challenge. I mean, like it could be amazing to play it all together.
No, I'm thinking
But
about
maybe next time. Maybe next time we
no.
can make
Yeah.
it multiplayer.
Yeah, there may be difficult to sync with the connect. Maybe there would be some issue with network connection if we just use WebSocket. But with one node server dealing with these connections and syncing these two positions of players, that would be that.
But you can I mean, you don't need to develop a WebSocket instance for that. There are lots of things, SAS, I mean, SAAS for WebSockets. Like you can just, I mean, yeah, like you can just buy a pusher that can, it works fine. I mean, you can do it with Python. Let's imagine you can push it from Python or subscribe JavaScript. You subscribe like that, and this is the input actually. Like, yeah, I mean, like you can, like you can. There are some devices that you can use in your like homes, like it's IoT, and you can program them with Python. In these devices, you can actually listen to some channel. Let's imagine when the light bulb is open or something like that, or when something happened in your flat, you can make the bird flying. Yeah.
Well, that would be a very interesting project.
Yeah.
You know, to create this game, I think
Yeah.
creating the game itself, it would be easy, but very interesting would be creating this multiplayer. So you kind of broadcasting your position and getting position from the server of someone else position who broadcasted it. So and
Exactly.
then colliding, yeah, and then this engine which would kind of search for collisions or something. That would be, this could be like a fight between something. Yeah.
Yeah. Yeah, as I said, yeah, it's an experience itself, the like developing a game, and like it's like yeah, like you can be very creative with it. You can connect this with, like, for instance, step meter, something like that. When you actually run, let's imagine when you run, the bird will fly, and like you will be running, and at the same time bird will be flying. So it's also possible, and it's not hard at all. As I said, like they are all loose coupled, they are all like encapsulated as well, and you just need some input, and you need to like trigger some event in this game. Yeah.
Yeah, one
And
thing here is if we, for example, want to animate this bird which is flying, we could use. How do you
okay,
think how we could do that? If we want to
can
like
we?
create a
Yeah,
real
like
bee.
yeah, sure. I mean, okay. Let's do it on Keynote. Right to the left. No change. Moving. I mean, let's say confetti. I mean, yeah, like I. Hmm, I don't know
I
how
was more
it's.
thinking about two small JPEGs, and then they could show a
Okay.
bird as a, the wings down and up, and then you kind of switch between the views. Yeah.
Actually, did this? It was a blueprint of the game. I mean, yeah. Actually, that's how it works. Like, actually, this is a PNG file. I mean, can you see the bird flying?
Yes.
Oh, okay. Actually, this is a PNG file, something like that. So it's actually, yeah, like this is called sprite sheet, and like you have a sprite sheet, very big sprite sheet, and you basically it works like in CSS. So at the first frame, we just show the first part of, we draw a line here. In the first frame, we show this. In the second frame, we show this.
Yeah, so we have 4 frames and we show them in the
Yes.
so it simulates the flying.
Yeah. Actually, the original game was something like that, but this, yeah. And the class is this. The class is so the class keyword at that time, yeah, in 2014, we took it from John Res. John Resig is the author of the library jQuery. So this is actually a very like not simple. Sorry, like this is a simple, but at the same time a complicated piece of code in JavaScript that allows you to create classes. But of course, you don't need to do that. I mean, the function is a class in JavaScript. Like you can, I mean, we are basically emulating the classes with functions. This is implemented by John Resig. Anyway, you can check it. So, yeah.
Okay, thank you. For me, actually, it was quite easy to understand all this. I think that this may be a bit confusing for people who didn't have any experience before with any canvas related things. But the keyword is here. Just start with canvas, and then with help of JavaScript, you can create a game quite easily.
Yeah, like simply create like some simple thing. Let's imagine you will like there will be 2 buttons, increase and decrease. When you plus increase, the number will be updated, like +1, and when you when you press minus, the number will be decreased. Something like that. Start with that kind of a simple game, then evolve it. I mean, if you consider the game development itself as a game, and if you follow let's imagine like natural selection, etc., you will just try. You will make hundreds of or like 10 I mean, like numbers of the, let's say, levels, and you will get the best of them. Then the next day you will do the same, and the next day you will do the same. And it's more like a journal actually, but you're actually building a game.
Yeah, once you get moving with the buttons up and down something, you can make JavaScript to do it for you and interact with this. Yeah.
Yes, exactly. That's the most exciting part of game development.
I quite fast went from this moving part up and down to creating something similar to Pac-Man. So just imagine that someone some time ago wrote this
Yeah.
Pac-Man, sell this for $1 million, trillions, and basically we developers can create this after a few weeks of playing with canvas, and we can create something like Pac-Man. Then you just add like all these displays of the records, the score, and that the rest is quite easy. So it's quite interesting and different completely topic to just creating single page applications. All right, that would be all from my side. I don't see here any questions.
Yeah, we have none.
Alicia, I can step in and close the meeting. Thank you.
Okay, so thank you, Pavel. Thank you, Fari, for your presentation. That was very, very nice. And what else I wanted to say? Well, I wanted to say that anyone who's interested in like presenting, you can contact us through our media. I think you should be able to see it in a second. You can find us on Facebook. We can answer any of your questions there. You can find us on YouTube, on Twitter, on Instagram. There's also our website, Rolling Scopes. You can find us there as well. And yeah, if you want to present anything, you want to share knowledge, you have like interesting showcase that could be helpful to anyone, or you think that could be helpful to anyone, just contact us and you can be our next presenter. Also, if you want to join our Rolling Scopes school, the you can still roll in, you can still enroll because it will start in 4 days, so there's still plenty of spaces that you can enroll to. And yeah, thank you for your attendance, and I hope that we can see each other soon.